In the previous session, we just defined interference of light. What is interference of light? The modification in the distribution of light energy when two or more waves are superposed on each other. In this session, we discuss about the types of interference of light. There are two types of interference of light. They are constructive interference and destructive interference. Constructive interference and destructive interference. Let me first discuss about constructive interference. In constructive interference, crest of one wave falls on the crest of another wave, and trough of one wave falls on the trough of another wave. Crest of, this is a wave. Let us consider one more wave. Crest of, this is crest and this is trough. Crest of one wave falls on the crest of another wave, and similarly trough of one wave falls on the trough of another wave. This is known as constructive interference. This is the crest of one wave, that is C1, crest of second wave, that is C2. This is trough of first wave T1, this is trough of second wave T2, that is crest of one wave falls on the crest of another wave, and trough of one wave falls on the trough of another wave is known as constructive interference. In constructive interference, the amplitude of the resultant wave will increases, because crest of one wave falls on crest of another wave. The amplitude of the resultant wave will increases. As the amplitude of the resultant wave increases, its intensity also increases. That means intensity is maximum. Intensity is maximum during constructive interference. Intensity is maximum in constructive interference. As a result of this, bright fringes are obtained. Bright fringes are obtained during constructive interference. Okay. So in constructive interference, the waves are in phase, same phase. The waves are in phase. In constructive interference, two waves are in phase. Two waves are in phase. Okay. What is constructive interference? When crest of one wave falls on the crest of another wave, trough of one wave falls on the trough of another wave, then it is known as constructive interference. In constructive interference, the amplitude of the resultant wave will increases. Therefore, intensity is also increases, because I is directly proportional to A square. Amplitude is, intensity of the light is directly proportional to the square of its amplitude. As amplitude increases, intensity also increases. That means intensity is maximum in the case of constructive interference. Therefore, bright fringes are obtained in the constructive interference. So, in constructive interference, two waves are in phase. Okay. Next type is second type, that is destructive interference. Destructive interference. So in destructive interference, crest of one wave falls on the trough of another wave, or trough of one wave falls on the crest of another wave. In the constructive interference, crest falls on the crest and trough falls on the trough. But in the destructive interference, crest of one wave falls on the trough of another wave, or trough of one wave falls on the crest of another wave. As a result of this, the amplitude is minimum. The amplitude of the resultant wave is minimum or even zero. So if amplitude is minimum, then intensity is also minimum. Intensity is also minimum. So dark fringes are obtained during destructive interference. Okay. So if two waves are here, the two waves are out of phase. Two waves are in out of phase. Okay. If crest of one wave falls on the trough trough of another wave or trough of one wave falls on the crest of another wave, then it is known as destructive interference. In destructive interference, the amplitude is minimum, so intensity is also minimum. As intensity is minimum, dark fringes are obtained from this destructive interference. So in the destructive interference, in destructive interference, two waves are in out of phase. Okay. Then, what is the difference between constructive interference and destructive interference? First point is, crest of one wave falls on the crest of another wave. Trough of one wave falls on the trough of another one. The crest of one wave falls on the trough of another wave, or trough of one wave falls on the crest of another wave. The amplitude is maximum. The amplitude is minimum. Intensity is maximum. The intensity is minimum. Bright fringes are obtained. The dark fringes are obtained. The two waves are in phase. The two waves are in out of phase. These are the difference between the constructive interference and destructive interference. Next, theory of interference. Consider two coherent sources. Consider two coherent sources. What is coherent sources? The source which emits light of same frequency and same wavelength with constant phase difference. Consider two coherent sources, X1 and X2. They emit light of same amplitude and same frequency with constant phase difference. Let us call this source as S1 and this source as S2. These two sources emit light of same frequency and same amplitude, and they meet at a point called P. The two sources S1 and S2 emit light of same amplitude and same frequency, and these two waves are superposed on each other at a point P. That means interference pattern is obtained at a point P. Let the displacement of the first wave, due to source S1 is given by y is equal to, usually displacement is given by y is equal to a sin omega t. Here we consider two sources, so we call this as y1. So y1 is equal to a sin of omega t. Here what is a? Where a is the amplitude. A is the amplitude of the wave. Omega is the angular frequency, and t is the time. Okay. Similarly, the displacement of the wave due to the source S2, due to the coherent source S2 is given by y2 is equal to a sin of omega t plus 5. A sin of omega t plus 5. Here we return amplitude of first wave as A and second wave also A, because these two are emitted by the coherent sources. The coherent sources emit waves of constant amplitude. So here A is also amplitude, omega is the angular frequency. But the second wave has a phase difference of 5 with respect to first wave. Therefore, this can be written as y2 is equal to a sin of omega t plus 5. Then 5 is the phase difference. Then, according to the principle of superposition, the resultant amplitude, the resultant displacement is equal to the sum of individual displacement. According to the principle of superposition, the resultant displacement is equal to the vector sum of individual displacement. That is y is equal to y1 plus y2. Therefore, y is equal to y1. What is y1? So, y1 is a sin omega t plus y2. What is y2? A sin of omega t plus 5. Okay. The common factor is a. Therefore, y is equal to a into sin of omega t plus sin of omega t plus 5. So, it is in the form of sin a plus sin b, where a is omega t and b is omega t plus 5. So, it is in the form of sin a plus sin. So, this equation is in the form of sin a plus sin b. But sin a plus sin b can be written as 2 sin of a plus b by 2 into cos of a minus b by 2. Apply this formula. There a is what is a? Omega t, and b is omega t plus 5 by 2. A is omega t and b is omega t plus 5 by 5. So this equation becomes y is equal to a into sin of a plus b by 2. Sin a plus sin b is 2 sin of. So that can be written as a into 2. That is 2a into sin of. That's why a into 2 sin of a plus b by 2. That a is omega t plus b is omega t plus 5, that divided by 2 into cos of a minus b by 2. Again a is omega t minus b is omega t plus 5, that divided by 2. Okay. So here we take 2 as common. So y is equal to 2a into sin of omega t plus omega t is 2 omega t plus 5, that 4 divided by 2 into cos of omega t plus into minus minus omega t plus into minus minus 5, that divided by 2. Okay. Next y is equal to 2a into sin of, divide this 2, that is 2 get cancelled, then sin omega t plus 5 by 2. Sin omega t plus 5 by 2 into cos of plus omega t minus omega t get cancelled, remaining is cos of minus 5 by 2. But we know that cos of minus theta is equal to cos theta. The cos of minus 5 by 2 is equal to cos 5 by 2. So this equation becomes y is equal to 2a into sin omega t plus 5 by 2 into cos of minus 5 by 2 become cos of plus 5 by 2. Cos 5 by 2. By rearranging this equation, you will get y is equal to 2a cos of 5 by 2 into sin of omega t plus 5 by 2. Okay. Here the factor 2a cos 5 by 2 can be taken as resultant amplitude. So this equation becomes y is equal to r into sin of omega t plus 5 by 2, where, so this is the resultant displacement. Y is equal to r sin of omega t plus 5 by 2, where r is the resultant amplitude, omega is the angular frequency, and phi is the phase frequency, where r is the resultant amplitude. So this resultant amplitude is given by r is equal to 2a cos of 5 by 2. This is the resultant amplitude. During interference, the resultant amplitude may be increased or decreased. In constructive interference, this resultant amplitude amplitude will increases, but during destructive interference the resultant amplitude goes on decreases. Then the resultant amplitude is given by R is equal to 2A cos of 5 by 2, where A is the amplitude, the individual wave. Don't confuse this A with R. R is the amplitude of its resultant wave. A is the amplitude of the individual wave. Phi is the phase difference. By using this, we obtain the condition for constructive and destructive interference. First one is the condition for constructive interference. Condition for constructive interference. You know that for constructive interference, first of one wave falls on the first of another wave, and trough of one wave falls on the trough of another wave. As a result of this, the amplitude of the resultant wave will increases. As the amplitude of the resultant wave increases, its intensity is also maximum. If R is maximum, what is R? R is the amplitude. If R is maximum, then intensity is also maximum. Intensity I is also maximum. But we know that intensity is directly proportional to the square of the amplitude. Okay? So here I square of the amplitude. We will write here as amplitude. Square of the amplitude. So intensity is directly proportional to what is amplitude here? 2A cos phi by 2. 2A cos phi by 2, that whole square. This becomes I is directly proportional to squaring this, that is 4A square cos square phi by 2. Here the intensity is maximum only when cos phi by 2 is equal to 0 plus or minus 1. Intensity is maximum only when cos phi by 2 is equal to plus or minus 1. Apply this here, that is intensity is maximum when cos of phi by 2 is equal to plus or minus 1. This cos of phi by 2 is equal to plus or minus 1 when cos of phi by 2 is equal to 0, pi, 2 pi, 3 pi, etc. Or phi is equal to cos phi by 2, this cos of phi by 2 is equal to plus or minus 1 only when phi by 2 is equal to 0, pi, 2 pi, 3 pi, etc. Or phi is equal to 2 into 0 is 0, 2 pi, 4 pi, 6 pi, etc. Okay. So in general, this can be written as phi is equal to n 2n pi. Phi is equal to 2n pi. In general, phi is equal to 2n pi, where n is the integer, that is n is equal to 0, 1, 2, 3, etc. If you put n is equal to 0, then you will get phi is equal to 0. Suppose we put n is equal to 1, that is 2 into 1, that is 2 pi. If you put n is equal to 2, you will get 2 into 2, 4 pi, like that. In general, this can be written as phi is equal to 2n pi. This is the condition for constructive interference in the case of phase difference. But for path difference, next condition for constructive interference in terms of phase difference, path difference. So we know that path difference is equal to lambda by 2 pi times of phase difference. Path difference is equal to lambda by 2 pi times of phase difference. So this path difference is equal to lambda by 2 pi into phase difference can be written as 2n pi. So pi will cancel, 2 will cancel. Remaining path difference is n into lambda. This n lambda. This is the condition for constructive interference in terms of path difference. Okay. Remember that for constructive interference, path difference is phi is equal to 2n pi, and for constructive interference, phase difference is phi is equal to 2n pi, and path difference is equal to n into lambda, where n is the integer. Next we shall do a condition for destructive interference. Destructive interference means crest of one wave falls on trough of other wave, or trough of one wave falls on the crest of another wave. That means the amplitude of the resultant wave will decreases. As amplitude decreases, intensity is also decreases. That means amplitude and intensity are minimum in destructive interference. We know that the resultant amplitude is given by R is equal to 2A cos of phi by 2. This resultant amplitude is directly proportional to the square of the intensity is directly proportional to the square of the resultant amplitude. That is, I is directly proportional to 4a square cos of phi by 2. Here, I is minimum when cos of phi by 2 is equal to 0. When cos phi by 2 is equal to 0. Therefore, here I is minimum during destructive interference. Intensity, if intensity is minimum only when amplitude is minimum. Amplitude is minimum. That is, this amplitude is minimum when cos of phi by 2 is equal to 0. This cos of phi by 2 becomes 0 when phi by 2 is equal to pi by 2, 3 pi by 2, 5 pi by 2, etc. Or phi is equal to 2 get cancelled, remaining is pi multiplied by this 2. So 2 get cancelled, remaining is 3 pi. Again 2 get cancelled, remaining is 5. Cos of phi by 2 is equal to 0 when phi by 2 is equal to pi by 2, 3 pi by 2, 5 pi by 2. Or phi is equal to pi, 3 pi and 5 pi. In general, this can be written as phi is equal to 2n plus 1 pi. This can be written as phi is equal to 2n plus 1 pi. So this is the condition for destructive interference in terms of phase difference, that is 2n plus 1 into pi, where n is equal to 0, 1, 2, etc. If you put n is equal to 0, then you will get pi. If you put n is equal to 1, you will get 1, 2 into 1, 2 plus 1, 3, that is 3 pi. If you put n is equal to 2, you will get 2 into 2 into 2, 4 plus 1, that is 5 pi. Like that. Okay. Next we will write condition for destructive interference in terms of path difference. Path difference. Again we know that path difference is equal to lambda by 2 pi times of phase difference. So path difference is equal to lambda by 2 pi into the phase difference is, what is phase difference? 2n plus 1 into pi. 2n plus 1 into pi. And pi get cancelled. Remaining path difference is equal to 2n plus 1 into lambda by 2. So this is the condition for path difference, and this is the condition for destructive interference in terms of path difference. We recall that For constructive interference, phase difference is equal to 2n pi and path difference is equal to n lambda. For destructive interference, here phase difference is equal to 2n plus 1 into pi and path difference is equal to 2n plus 1 into lambda by 2. These are the conditions for constructive and destructive interference in terms of phase difference and path difference.